So I'm here today to talk to you about some of the security capabilities within OCI. So a little brief introduction about myself. I'm a cloud architect who works in technical pre-sales within Oracle in the UK. And my focus is central government and policing, which obviously goes hand in hand with high secure um, environments. So the key thing to point out is that OCI has lots of rich security capabilities. And everything I'm going to demonstrate to you today is free. There isn't any additional cost for anything to run, unlike some of the other hyperscales which charge for some of the more enriched security capabilities. In a lot of instances, I see that the security capabilities that are available are either misunderstood or neglected, which leaves customers in potentially dangerous situations, especially at the minute when there's like a really big buzz about, deploying AI applications. And sometimes security can be a little bit of an afterthought. But I want to demonstrate to you today is it really should be the foundation for any deployment that you put together. And security is not just a tick box one-time exercise. It's a continual process that you need to kind of bake into your BAU processes to ensure that you're a step ahead of those nasty people that want to attack you, as Reshma touched upon. So the idea behind the session today, I can't cover everything security-wise with an OCI because you'd probably need to hear me ramble on for a week, but I'm going to pull out some of the key capabilities that you can use, speak a little bit about them so you understand exactly what they are, but importantly, give you a quick demonstration so that hopefully if it's something you may be not currently using, it's a capability that you can assess and potentially look to deploy within your tenancy. Now, to keep things as simple as possible, I've broken up the four capabilities that we will look at into kind of different sections. So we look at security zones, which essentially are there to prevent attacks from occurring, making sure that you don't do anything too stupid within your tenancy and enable something that would enable a service that would open an attack vector within your tenancy. We then look at Cloud Guard, which is a little bit more like a detective. So whereas the security zone is very kind of proactive, Cloud Guard's more reactive, but gives you good insight into potential issues within your tenancy and exactly how you can look to resolve them. I'll then speak about a fantastic service that we've got called the Security Health Check for OCI, run you through exactly how you can execute that to assess the security configuration within your tenancy, identify any specific pain points, and also importantly, put together a plan for how those could be remediated, again, to ensure that your security posture is as strict as possible. And lastly, we will look at the Bastion service, which helps to secure connectivity to compute VM instances within your tenancy and other service too. This is a really good selling point for OCI actually, because a lot of other hyperscalers actually charge for this service, but we include it absolutely free of charge. And when you do need access to VMs and services that sit within your tenancy, Bastion really should be your first choice rather than doing anything nasty like connecting directly over the internet services. We'll speak more about that later. So we'll initially take a look at security zones, which I've put in the category of prevent. Now, 95% of data breaches that occur are actually caused by human error. It's not poor software. It typically is somebody's made a mistake with the configuration, which is obviously quite a significant percentage of data breaches that occur. And a really good example of this, which is famous, is there's a hole in my bucket. So which is object storage, which is pervasive across all hyperscalers. It's a nice, easy, typically cheap way to store lots of data in the cloud. I guess its biggest advantage is also its biggest disadvantage in that you can put a bunch of data in the cloud, but if it's not secure, those nasty hackers can get hold of it. And if you do a quick Google search or your search engine of choice to just have a look at kind of public bucket security vulnerabilities, you'll see that it's absolutely littered with instances where, in many cases, really big corporations have object storage buckets that they've made public, which essentially means that anybody on the internet can get access to them without any credentials. And over the last few years, this has caused all sorts of security vulnerabilities, security attacks. And I've included some really good, probably really bad examples actually, of where companies have had storage buckets that have been configured and anybody anybody and everyone could get access to those across the internet, which is obviously not how it should be. They should be secured, usernames and passwords, and only available to the employees within the organization. Now, this is where security zones come in. So rather than having to kind of reactively scan the environment to see if you've got any things like object storage buckets that are available publicly, or, you know, nag your operations team to make sure that they don't configure buckets publicly. What security zones actually do is it prevents misconfiguration. So within OCI, the security zone service can be configured, and there are about 70 to 80 individual settings to block certain configurations. So within your tenancy, if you would never ever have the desire, need, or requirement to make a virtual machine instance available publicly or over the internet, or a storage bucket, what you can do with the security zone is configure a policy that would actually block the creation of that configuration, which means that, let's say somebody's maybe not trained up or missed the memo on what they should and shouldn't do with a tenancy, tries to do something that's not pre-approved, such as creating a public VM instance. What the security zone service will actually do is it'll block the creation or the configuration, which keeps you kind of safe, ensuring that only pre-approved configurations are allowed within your tenancy. It'll essentially just block creation of any resources that contravene the policy. It does apply a level of flexibility too. So if you've got quite a large, complex tenancy, there may be some content that you do need to make available publicly. Now, within the configuration, you can change the security zone config so that it's different depending on whereabouts the content is within the tenancy. And I'm always one for like a good analogy, because I think that makes life a little bit easier to understand kind of exactly how something is. So imagine a security zone. If you go bowling, especially with small children, you've got these little bumpers that you can pop up to make sure that they enjoy the game and kind of nothing goes down the side. Imagine a security zone. It's like a permanent safety rail. So it's a bowling lane where the bumpers are essentially welded up and cannot be lowered by anyone, which makes gutter balls impossible. And if you think in an analogy from IT, a gutter ball could be creating a public storage bucket, something that we deem to be dangerous, that shouldn't ever occur. And essentially, it's there for success. You don't need to double check your work, and it guarantees that every resource stays within safe boundaries according to the policies and restrictions that you have within your organization. Now, a picture paints 1,000 words. So what I'll do is I'll take you through configuring a security zone within an OCI tenancy. So if I go to my test tenancy that I have, and I then go to identity and security and to security zones, what we'll see is we have a number of recipes. So by default, we've got this Oracle managed recipe that's got a bunch of configuration settings that can potentially be blocked. Now, let's say we have a specific requirement to block the creation of VM instances of a public IP address. What we could do is create our own recipe. So I'm going to call this my recipe. And then within it, we can select the specific policy that we're interested in. So in this case, out of the 80 or so policies that are available, we're just going to select the option to deny public subnets, which will deny any machine that has a public IP address from being created. So once we've created our custom recipe that has that essential one setting, what we can then do once we have the recipe is apply that. And what I'm going to do here is I'm going to create a security zone, which essentially is a mapping between the policy and a compartment or the container within OCI. So I'm going to give the security zone a name of demo, and I'm going to choose a recipe called my recipe that we've just created. And that's been assigned to my demo compartment. So essentially, any resources within that compartment need to apply to that security zone policy, which blocks the creation of public subnets. Now, after about 30 seconds or so, what should happen is that policy should come to life. And now, if I then go to my networking configuration and go to one of my existing networks that I have, you'll notice I've actually got a public subnet there. Anything that was created prior to it will be permitted. It doesn't block existing resources, but anything new that's created that contravenes the policy will be blocked. So I'm going to attempt to create a subnet here that is available publicly. So I'll put in all of the configuration settings that are required. ensure that public subnet is selected there. And then if I click the create subnet button at the bottom, what we should see is a little nasty red error message. So essentially it's completely blocked me from creating that configuration. It's also worthwhile pointing out that whilst it doesn't block existing resources that have been created, what it will actually do is because you've put the policy in place, it will flag it up um, within the security zone itself. So we saw that it blocked. I couldn't create that public subnet. However, if we look at the security zone, it actually integrates with CloudGuard, which we'll speak a little bit more about later. And what we can see here is it says within the demo compartment, you've got this policy assigned. We're actively protecting it. However, there are currently two problems that are found, which are based on existing configurations. And I can then click that link into CloudGuard. It'll take me through and I can see exactly where those policies have been contravened, and I can then make a call as to what I need to do, whether to back out the configuration or potentially treat it as an exception because maybe it's something that is actually required. So we'll next take a look at CloudGuard. So as I touched upon in the security zones piece, CloudGuard is used to surface configuration errors from existing configurations where you have policies in place that do block them. And the way that I determine CloudGuard, it's more detect. So whereas security zones are more prevent, CloudGuard's more reactive. It actively scans the tenancy and looks for things that don't look correct or can be optimized or improved. So if a security zone is a guardrail, CloudGuard is more like a detective. It helps to maintain a really good security posture by detecting weak security configurations and also any activities that could indicate security risks, such as an end user maybe logging in from a foreign location or country. The two primary constructs that are used within CloudGuard, one is a detector, which as the name would suggest, is the functionality within CloudGuard that actually scans the tenancy, looks for potential issues, and essentially detects them. The second piece of that is the responder. So not only can CloudGuard actually identify security risk issues within your tenancy, it can also resolve them. So what we'll see when I do the demonstration, we can actually go in and look at a configuration. We can look at an issue that's been detected, and there's a little button that we can click to fix it. And the bit that fixes it is a responder. So essentially, we've got both sides of the coin. We can identify issues and then automatically do the fix for them, saving valuable time. And the way to look at CloudGuard, it watches what you've already done and alerts you or fixes it if it looks insecure. Now, setting up CloudGuard is super simple, and I'll take you through a really quick demonstration of how to configure it end to end. So if we go into our tenancy and then go to identity and security and then select CloudGuard, if you've never configured it or set it up, what you will get when this page launches is a nice pretty button that says enable CloudGuard. What this does is it needs to add a bunch of policies to the tenancy to give the CloudGuard service permission to actually read resources and read their configuration. The second piece of information is where to enable the policy. So by default, you can enable it at the root, which basically means everything tenancy-wide. You can, if required, enable CloudGuard purely within a smaller section of the tenancy, but the default is to enable it tenant-wide. And once you've enabled it, it gives you a quick little tour that takes you through exactly the key capabilities within CloudGuard and what can be used for what. With that being said, a picture paints 1,000 words. So what I will do here is take you through actually my tenancy itself. So let me just quickly flip here. So if I go to Identity and Security and CloudGuard, this will take you through to my tenancy itself. You can see it's got an overall good rating. Security score goes from 0, which is obviously very poor, up to 100, which is excellent. You also get a risk score. So risk score is based upon the number of issues that it's found and also how pervasive they are as well. And on the right-hand side, we've got our list of recommendations, which is a really nice way to quickly go in and see the key issues that it's identified within the tenancy. As this is my test tenancy, it's certainly not used for any production workloads. It's the quick demonstrations and things. You can see it's It's probably not in great shape. It's identified a few issues that could be resolved. So, for example, I've got some public buckets. I've got machines that require to be patched. So the recommendations gives the top 10 recommendations I can do to improve the security posture. If you go into the problems section, it'll actually give you a list of every single problem it can find within your tenancy. So if we go to the top one, scanned host has vulnerabilities, what CloudGuard's actually done is seen that I have a virtual machine within my tenancy. It's done a security scan and it's actually seen that it's missing a lot of security updates, which means that I should probably get this patched. It can also identify other issues. So the fact that I've got an instance that's publicly accessible, it's flagged that up as a critical issue. Now, there are two things you can do with an issue. Let's say, for example, it's something that you're happy with. Yep, this instance should be publicly accessible. Maybe it's hosting our public website. If it wasn't available publicly, we wouldn't have a website. So please ignore it. There's actually a little button here that you can click to mark as resolved. You give it a comment, which obviously needs to be descriptive to explain why that was the case. The really cool piece is this little remediate button. So what you can do literally with a couple of clicks is click this button and then click remediate. And what it will do is it'll go off and delete the public IP addresses for it. So saving time and just helping to improve the security posture. So that is CloudGuard and my tenancy and the shape that it's in at the minute. The next capability to look at, strictly speaking, isn't a feature of OCI. It's a value-add service that is provided called the OCI Security Health Check. This falls more in the assess space, a little bit similar to CloudGuard, but takes a slightly different approach to it. And the way that I look at this is you can't manage what you don't measure. It's really important for you to have a security baseline of your tenancy that you can regularly review over time to ensure that you stay in the green, that there aren't any new insecure configurations or areas that you can improve. So what there is a service called the OCI Security Health Check, completely free of charge, available for download publicly. And what it does is it assesses the security posture of an OCI tenancy against the best practices that are outlined in the Centre for Internet Security benchmark for OCI. So for those of you that are not familiar with the CIS benchmark, pretty much for all of the hyperscalers and all of the kind of key application vendors globally, the Centre for Internet Security work with the vendor to kind of review and provide prescriptive guidance on how to improve the security posture from the default of those applications or clouds. Now, for OCI, the Centre for Internet Security have created a benchmark. Now, what the OCI Security Health Check does is essentially take all the guidance that's included within that benchmark, review the configuration of a tenancy against it, and then provide a report that outlines both the good, so areas where you fall in line with the security guidance that's provided, and also the bad, in addition to providing practical remediation guidance. So if it flags up anything that looks a little bit iffy, that doesn't follow the CIS guidance, it will also give you recommendations on exactly how you can go about fixing that. And the way that I typically position this to customers is it's a great idea to benchmark a tenancy, but then also to rerun it regularly to identify any new issues. So, for example, you could run it each month just to make sure that there's not any misconfigurations that have crept in. The other thing to point out is that the CIS guidance is updated quite regularly. And in fact, it was updated at the beginning of this year. Therefore, the health check is updated typically around a similar time too. So you might find that the overall guidance has been updated and something that previously was deemed as not an issue now is potentially deemed as insecure. So by keeping on top of that, again, it keeps you a step ahead of the attackers. And the reason why I'd recommend this is mainly because I'm lazy. So the tool is simple to run and easy to understand as the heavy lifting has been done for you. And the reason for that, the CIS benchmark isn't a couple of pages of do A, B, and C and you're good. It's literally 219 pages of guidance. So for somebody to read that information, digest it, and manually perform the checks against the tenancy would take a ridiculous amount of time. And also with human error, there'd likely miss configurations too. And I'll just quickly demonstrate what that document looks like. So it's this. It's really good as a practical reference, but in terms of having to go through it, digest it, understand everything, go through their guides and how to verify it, you probably have to lock yourself away for a couple of weeks to do that. So by having a tool that can literally do it in a few minutes, makes your life a lot easier. And what I will do now is take you through how to run the security health check in three simple steps. So the easiest way to run it actually is from within your OCI tenancy using CloudGuard. It can using Cloud Shell, sorry. It can be run remotely, but the quickest and easiest way typically is to use Cloud Shell. And the way that we do that is within our tenancy, if we log in, we can select the Cloud Shell option. This is pre-recorded, so it's obviously took me a little bit longer to record the click. Right, sorry about this. Right, so what we do, we're logged into our tenancy, we go to developer tools, and then we go to the Cloud Shell, which allows you to run commands against your tenancy. You could do it locally, but like I say, it's easier because it runs within a browser, it's available there. And there are just some simple commands to run. So the first thing that we'll run is the command that will actually download the health check from its public location. So we've got that now stored locally. The next thing that we need to do once we've got that is a zip file. We need to unzip it. And once it's been unzipped, we can just jump into the directory where the health check is. And then we just need to change the permissions on the file that actually runs the health check, which is the standard.sh script. And once we've done that, it's as simple as running that script. It goes off, doesn't require any other configuration. It collects all of the information from the tenancy, compares it against the CIS guidance, and then produces an output report. Key thing to point out here is I'm running this as a user with admin privileges to the tenancy. You obviously need to make sure the user account user has sufficient permissions to be able to extract the information required to actually do the assessment itself. For my tenancy, which is pretty small, probably only took about 5 minutes to go through. Now, once it's completed, you've got the output from the security health check. However, it's sat within Cloud Shell on some machine. So what we need to do is we actually need to download that locally so that we can take a look at the report. And it actually provides you now as part of the tool the exact command you've got to run to do that. So we've hit this little cog. There's a little download button. We can pass it the path to the file that contains the output from the security health check. That should take a few seconds to download. And then once we have that on my local machine, we can jump into it and extract the information. So if we go here, and there we go, we've got our folder. Now, what you've got within here is there's a HTML report, which I'll demonstrate in a moment. But for each area that's identified, analyzed, there's actually a CSV file that contains a lot of rich information that's been captured as part of it. So in some instances, the report might say there's an issue, but you might have to jump into the CSV file to just get that deeper information on exactly what resources are impacted. And again, a picture paints 1,000 words. So what I've got here is an example of this was run against my tenancy some time ago, and what we'll see is a list of the issues that it's found. So it gives you details of kind of what you're compliant against, which is the good stuff, which is green. So you can give yourself a pat on the back. But importantly, it gives a breakdown of all of the areas that you're not compliant. Gives you details of kind of which specific area of the CIS guidance it's contravened, and background information that was collected that flagged it up, which is good. So you've got all of these recommendations, which are pretty clear. Then at the bottom of the report, what it actually provides you with is more prescriptive guidance on exactly how to resolve this issue and a little bit more information on what was actually collected from that. If we go back to the video I've got here, I'll show you the latest version of the report, which does look slightly different to that. So what you typically get at the top of the report, and this was the newer version that I run last week, is you get this nice little pie chart that shows you kind of where you're compliant and not compliant. As this is my test tendency, it's not the best shape, but it does give you a good overview of kind of how you're doing. And when you do the benchmark, if you do like a regularly, monthly, or quarterly benchmark, it's quite a good way to just see kind of how you're stacking up and if there are any kind of major changes there, which you can then work through those issues to hopefully get as many of them as addressed as possible. Or in some cases, they may have been configured that way, which might contravene the guidance, but actually makes sense for your organization just due to the way that you're using OCI. So security health check, like I say, it's completely free. I will, in the follow-up that we send, we'll include a link to the tool set that you can download. Probably take you less than an hour to run it, but at least then you've got a really good point in time benchmark and it will identify any security issue that you should look to go after and resolve. Now, the last security capability to take a look at is OCI Bastion. What this service does is it provides restrictive and time-limited access to VM instances that don't have a public IP address, typically via SSH if it's a Linux machine, or if it's a Windows Server Remote Desktop Protocol, or RDP. And the reason for this is it avoids making VM instances publicly accessible. So I still now see customers that maybe don't have VPN or fast connect in place that need to jump onto a VM with an OCI to do some administration, and they're basically accessing it directly over the internet, which is quite dangerous, which is why Bastion should be used in front of that as a protective measure. Even if you do have a VPN or a fast connect in place, you've got access between your on-premises environment and OCI so that you can access VM instances privately. Having Bastion configured is still good as a fallback if for whatever reason there's an issue with a VPN or the fast connect connection to OCI fails. And as we spoke about at the beginning about storage buckets being available publicly and some of the chaos it's caused, again, if you do a Google search for servers that are available anonymously over the internet, you'll see these massive issues, ransomware attacks, people reselling credentials. So having a machine that's available directly over the internet is very dangerous and puts your organization at severe risk. What Bastion does is help to counter that by adding an additional layer of security to ensure that you won't hopefully be affected by any of these nasty, horrible attacks that are occurring. So I've got a quick OCI Bastion 101. So the way that it is made secure is that you imagine if you're an end user here that's sat on premises, what you need to do is create a tunnel to the Bastion and authenticate to the Bastion so that it knows who you are, trusts you. Only then, when you are authenticated to the Bastion service within OCI, can you then make a connection to a server behind it. So it's essentially two-hop. You authenticate and connect to the Bastion, and then from the Bastion, you authenticate and connect to any servers that are sat behind it. Now, sessions to the Bastion service are time limited and can also have IP-ACL, so you can restrict it so that only specific addresses can connect to it. One Bastion is required per VCN. However, unlike other hyperscalers, the Bastion service within OCI is actually free. So it doesn't matter if you have one instance of it or 100, it doesn't actually cost you anything. It's included at no cost at all. And this example here gives it where you've got like a web server that's sat in a private subnet. So it's not available directly over the internet. So without a VPN or fast connect, the only real way you'd be able to get access to this is using Bastion, unless you were very naughty, put it in a public subnet so that it got a public IP address and everybody in the world could get access to it. So what I'll do is I'll take you through the end-to-end configuration of setting up the Bastion service and also creating a session to a Windows-based server um, from your local machine. So what I'll do first is demonstrate we've got a Windows server here. Doesn't have a public IP address. It's only available privately. And then if we go to Identity and Security, and hidden away the bottom right-hand corner is the Bastion service. And I don't have a Bastion within this compartment, so what I'm going to do is I'm going to select the button to create a Bastion. Give it a name. I'm just going to keep it as simple as possible. You then select the virtual cloud network to hook it into because you need one Bastion per VCN. And I'm also selecting the subnet. In this specific case, it needs to connect to the private subnet. You can add an additional level of security where you can specify which IP addresses can connect to the Bastion. I'm pretty much going against all of my guidance so far in this presentation, but for this demo, I've literally allowed any machine on the internet to connect to the Bastion. However, in the real world, you'd put in the IP addresses, the public IP addresses from your on-premises environment that you wanted to connect to the Bastion from. With that being said, you do still need to authenticate to the Bastion. So even if, for whatever reason, um, you have it wide open like me, the authentication is still required. You can also change the session timeout. By default, it's 3 hours. You could reduce that further if required to maybe something like 60 minutes or 30 minutes. Now, once that has been done, we can then create the Bastion. But once the Bastion's been created, it doesn't actually provide us access to anything. It's a shell of a service that's there ready waiting for us to use. What we need to do, as and when we need to connect to a virtual machine instance, we need to create a Bastion session. And that then allows us time-bound access to the specific machine within the virtual cloud network that we want to connect to. And the way that we do that is we go to the Sessions tab, select Create Session, select the session type. I'm going to be doing port forwarding because I'm going to be connecting to a Windows server. Otherwise, if it was Linux, you'd leave the default of a managed SSH session. Once I've selected that, what I can then do is select the instance that I would like to connect to. So I choose my compartment, which is my demo compartment we've been using. And then from it, it'll give me a drop-down list of all of the instances within it. In this case, I want to connect to my Windows server, which is actually called Windows. I then need to configure the port. So for remote desktop protocol, it's 3389. The next thing that we need to do is to generate an SSH key pair, which allows us to connect to the Bastion service. So this is that first step of authentication that I touched upon. And the way that we'll do that, you can either provide your own key or um, you can get the service to generate its own SSH key pair. What we'll do here is actually get the service itself to create the SSH key pair for us. So if we select that button here, and then we've got save private key, save public key, I'll store them locally in my machine. And that is what I will use to do the initial authentication from my local machine to the Bastion before I actually connect to the end server. Take a minute or two for this session to for the Bastion session to create. And once it's active, what you can do then is look at the SSH command, which gives you the command that you need to run to create the session to the Bastion. What I then need to do is from a terminal on my local machine, launch an SSH client. So I'll launch my terminal, and then what I'll do is I will grab the command that was provided by the Bastion service. And then we'll paste that in And when we're connecting to a server, there's just two pieces of information that we need to update the boilerplate command with. The first piece of information is the private key that was generated when we created the session. So we need to give it the location of that. Mine's just called ssh.key. I kept it nice and simple. And then we also need to choose the port on the local machine to listen on to redirect requests to. So what I've done here is I've configured it so that it listens on port 3390. What that means is anytime I connect to my local machine on that port 3390, he'll get redirected across to the Bastion. So it looks like I'm connecting to my local machine, but I'm not. It's actually getting sent down the SSH tunnel through the Bastion service to the backend server that I've got. Now, once we've updated those two pieces of information, so we've provided it with the key, we've given it local port to redirect access to, what we then do is hit return. And the one thing that kind of puzzled me a little bit when I did this, let me just, is we get this error message if you've never run this before, which basically means the private key file I've got has excessive permissions. I'll run into this every time I do it and I always forget to do it. So for completeness, the key thing to do is to run this command to change the permissions of the key file. Once you've done that, you can then run the command. You'll get a blinking cursor so it looks like nothing's happening, like something's processing in the background. The fact you've got a blinking cursor means the connection to the Bastion's there. And what you can then do is make a secondary connection to the server itself. So what I'll do now from my local machine is launch a remote desktop client and connect to the server. So I've got it saved there. And if we look at the configuration information, I'm essentially connecting to my local machine, but on port 3390, which, as we saw in the config earlier, is basically just redirecting that down the tunnel to that VM instance that we've got that sits within our virtual cloud network. So once I've updated that and verified that that is correct, what I can then do is double click the machine to connect. And what it should then do is send that traffic down the link to the Bastion and then to that backend server, which I can then administer as if I were sat in front of it, albeit virtually. So if we double click it, just ignore this pesky little warning. And there we go. So that's a nice way to get access to a server in OCI when you don't have VPN, you don't have fast connect, but without exposing servers to the internet. And like I touched upon, that's something I continuously see with customers. And it's like, please stop doing this. We've got a service. Whilst that demonstration may look a little bit complicated, there's quite a lot of moving parts to it. Once you've done it a couple of times, it's actually pretty straightforward. And, you know, those extra few seconds it takes to put the correct configuration in place is well worth it because of the decreased amount of risk that you've got to those instances. So just to kind of, I guess, touch upon key things today, we've looked at security zones, which are used to protect your tenancy, which are proactive. We've looked at CloudGuard, which is like the detective, which will have a little bit of a snoop around your tenancy. And if it sees anything that looks a little bit dodgy, it'll flag it up and also give you a really good score. We looked at the Security Health Check, which gives you a really good benchmark of your tenancy against the Centre for Internet Security guidelines, which are completely separate from Oracle, kind of externally vetted. And then lastly, we looked at the Bastion service, which is a practical way that you can get access to your servers without making them available publicly over the internet and potentially getting hacked and ending up all over the news. So thank you very much for listening to me. Hopefully you found it informative. And I think we've got time now for Q&A for any questions that you may have on anything that I've gone through.